In the next few examples, we are going to look at how we can use the ladder of powers to re-express data. So example 1 shows the population growth in the US from the year 1800 to 2000. We want to start with creating a scatter plot for the raw data. So raw data on our ladder is just the power of 1, meaning it's just the data that they give to us. Now, since these years are quite far from 1, we are going to scale the years as we enter the data. When we go to make that scale, we want to avoid using 0 and negative numbers. Oftentimes, we're going to use logs to re-express our data, and we can't take the log of 0 or of a negative. So I'm going to show you a few ways that we can manipulate this data using our calculator. Okay, let's go ahead and type our data into our calculator. So I'm going to go to Stat, Edit. I've already typed mine in, so go ahead and pause your video to type in your data here. Once you have everything typed in, we said that we want to manipulate this data a little bit so that it's closer to 1, make our numbers a little bit easier to work with. I want the starting year to be year 1. So what I could do is change this to year 1 and then kind of change all of these years and retype them in. To save you a little bit of time, scroll all the way up until L1 is highlighted, and we're going to tell our calculator to do the subtraction for us. So I'm going to type in L1, which is second and then 1, and then I'm going to tell my calculator what to subtract. So if I want this to be year 1 instead of 1800, I'm going to subtract 1799. When we hit enter, your calculator is going to subtract that amount from every single year. So it's a little bit easier, I think, than doing that subtraction by hand. Now that we've changed our data, it's a little bit closer to 1, we can go ahead and make a scatter plot. So I'm going to go to my stat plot, second y equals, making sure that I have a scatter plot, and then I'm pulling data from L1 and L2. Then I can press zoom 9, and here's my scatter plot. We're going to go ahead and take a minute to sketch. My x variable was the year, and then my y variable is population in millions. Okay, describing this scatter plot, we would definitely say that it is positive. So I'm going to say the scatter plot of years and population is positive. It's definitely curved for the form, but it also does look pretty strong. The dots are somewhat close together. I am not seeing any outliers, so I'm going to say no outliers. Okay, now the issue here is that this is a curved scatter plot. We want things to be as straight as possible. So we might think that the US population is growing by a certain percentage. So we might begin at the 0 power, which means we're going to be taking the log of our data. So back in our calculator, what we're going to do here is go to Stat, Edit. I'm going to scroll over to L3, and what I want to do is take the log of all my populations. I have my population typed into L2. So we're going to scroll up, highlight L3, and then we're going to type in what we want. So I'm going to press log, and then second 2 to pull up L2 right there. Once I press enter, my calculator takes the logs of all of those values for me. I want to see if logging this data made a difference. So I'm going to go back to my stat plot, which is second y equals. I still want a scatter plot, but instead of L2, I'm going to change this to L3. So second 3. I'm keeping my scatter plot the same here, so I can zoom 9, and now it looks like this instead. So So we're going to go ahead and sketch. Okay, so what happened here when I took the log of my data is it changed the curve completely. The direction of the curve now bends the wrong way. This means that I went too far on my ladder of powers. So if I look here, I started with raw data. We decided to try logs. That went too far. It changed the direction of the curve. So now we're going to move backwards. Let's try the square root. So I'm going to go back to my stat, edit. Your notes tell you to go to L4, but I would just go to L3 and clear L3 out. And in L3, I am now going to square root L2. So I'm pressing second x squared and then second 2 for L2, hitting enter, and my calculator does that work for me. Going back to my stat plot, pulling data from L1 and L3. L3 is now the square root of the population, and zoom 9 for my data. Okay, again, we are going to sketch this scatter plot. Okay, I am noticing that this scatter plot is much straighter than the last two, so I'm thinking that this is a good fit. So the next thing we'll do is create a line of best fit for this scenario. We're also going to graph the line of best fit just to see how that line compares to our data. So to make a line of best fit, we are going to stat, calculate. I'm still going down to linear regression here. But now I want to pull my data from L1 and L3. So I'm hitting second 3 to change that. And I also want to store my equation so that I can graph this. Once you're at store equation, we're going to hit vars, that stands for variables. Scroll over to yvars, press enter for function. And then you can pick where you want your calculator to store. I want it to store just in Y1, so I'm going to press enter here and then calculate. This is now giving me my line of best fit. So I'm going to go ahead and jot this down. My Y variable this time was the square root of the populations. So I'm going to put square root of population with a hat. I'm still predicting the population, but the difference is now I'm square rooting it. This is equal to my slope of 0.07 times my x variable, which was the year, plus my y-intercept of 1.39. Now, if I press graph, because we stored that line in our calculator, and I press graph, it's now going to graph that line of best fit for me. If I go to my y equals, you'll see the entire equation saved on there, not just the rounded version. So this is the most accurate graph that we can get. Okay, the last thing that we want to do is make sure to create a residual plot to check that a linear model is appropriate. We have our line of best fit, so we're going to go back to our stat plot, so second y equals. I'm keeping my L1, but I now want this L3 to be a residual. So to do that, I need my list, so I'm pressing second stat, going down to number 7 for residual, and then I can zoom 9. Here is my residual plot. Generally speaking, I'm thinking that this is quite random. It might have a little bit of a pattern, but for the most part, I'm thinking that it's random, so that means that a linear model is appropriate. Whenever we're doing these problems where you're re-expressing, my recommendation is to think of this as an actual ladder. So you are starting with your raw data. I would always recommend square rooting first. If square rooting didn't do enough, then you can keep working down the ladder. rather than just kind of picking a random one. So if you pick a reciprocal and it doesn't work, then you're kind of stuck. Do I go back to log, square root? What do? My recommendation is start with square rooting, and then you can work your way down if it goes too far. So like if the reciprocal changed the direction or changed your curve, then you can work backwards on that ladder. Let's go ahead and look at another example. So the following data shows mortgages from 1970 to 1988. We're going to start with typing in our data here. I'm going to zoom out a little bit. I am clearing my L1, 2, and 3, and I'm going to start with typing in all of the data. Okay, once my data is typed in, again, I'm noticing that I have years. They're quite far from 0. I want this first year to be 1, so I am going to go all the way up to my L1 and make this L1 minus 1969. That should start me off with 1, and now my numbers are a lot closer to 1, so this is going to be much, much better. Okay, ideally we are going, well in the end, we're going to create a model that's appropriate for this data, but we want to see what's wrong with it to begin with. So I'm going to my stat plot, making sure I have L1 and just L2. I want to start with the scatter plot of just my raw original data. So I'm zoom 9ing, and this is for my raw data. I am seeing a very clear curve. So I want to try to make this curve a little bit straighter. So let's go to our stat edit. Like I said before, I always recommend starting with the square root. So let's go ahead and square root our L2. Okay, my calculator did that for me. So I'm going back to second y equals. And I'm changing this L2 into an L3. Zoom 9 to see what happened. Now it does look like things got a little bit straighter. I'm not liking that my old line of best fit is there. So if you go to y equals, you can just clear that guy out. Now it's a little bit easier to see. So comparing my raw data to the square root, I think we're going in the right direction. It's getting straight. But I wish it was a little bit straighter. So thinking about my ladder of powers, my square root was okay. Why don't we try the next one, the log, and see if that is a little bit better. So going back to our stat edit into L3, I'm now going to put log of L2. In my stat plot, I'm good to go. I have L1 and L3. So I can zoom 9. I think this one is even better. This is definitely looking straight. If you don't trust me, or if you want to see if there's an even better one, you could go ahead and try the next step on your ladder, which would be your 1 over the square root of x. I think this is straight enough, so I'm just going to go with the log. So this was my log of $1 million. Okay, from here we want to actually create the model, so we're going to stat calculate linear regression. Make sure you're pulling L1 and L2. I'm not going to worry about storing my equation this time. I'm just going to calculate. When I go to write this in context, make sure you are remembering that your y values were being logged. So right now I have log of millions of dollars, and those are predictions. My slope is 0.07, and that's times the year. plus your b value, your y-intercept of 0.07 as well. Common mistakes on these problems: you forget to include your transformation. Make sure you are indicating what you used by telling that in your model. If you don't have this log right here, I have no idea what re-expression you used. Go ahead and pause your video. I want you guys to try example 3. Once you are done, go ahead and play the video to check your answers, and we'll talk through a few things. Hopefully when you graphed your raw data, you got something like this. It's a definite curve and it is decreasing very, very quickly. I went through and I started with square root. It changed it slightly, tried the log, changed it again, but it was still a little bit curved. So the next thing I did was look at the reciprocal square root. So that's your 1 over the square root. When I did that, I got a graph that looked like this. This is looking quite straight to me. So that's the one that I sketched here, definitely straighter. It did change the direction, but things are straight now, which is good. Doing our stack to calculate linear regression, pulling data from L1 and L3. Okay, when you go to write this line here, make sure that you are showing what re-expression you used. Your slope is pretty easy to identify, but watch out on this y-intercept. It gives you negative 5.5, but then there's this e to the negative fifth. This is a fancy way of writing it in scientific notation. So negative 5.5 times 10 to the negative fifth. Negative 5 is your exponent, is telling me to take my decimal and move it to the left 5 times. 1, 2, 3, 4, 5. So that's going to give me 4 zeros, and then your 5, 5. Pay attention to those e's there. You do not want to write it as just negative 5.5. That is very, very different than 0.000055. There is some practice on Canvas for you to continue working with using this ladder of powers and re-expressing data.